Good morning, everyone. Welcome to the first Innoaqua webinar about sustainability and circularity assessment of the innovative algae-based foods and solutions. We are going to wait 2 minutes and we'll start. I remind that we are recording session because we are going to upload the webinar to our YouTube channel. So yeah, just 2 minutes and we'll start. Thank you very much. Good morning. One minute. Okay, I think we can start. Welcome everybody to our webinar from Innoaqua project about sustainability and circularity assessment of innovative algae-based foods and solutions from technology to market. My name is Carlos León. I am the Chief Innovation Officer of Sustainn. We are a partner of the Innoaqua project, and we are leading the work package related to sustainability and circularity assessment with me, Ayelen and Dorinde. Ayelen is my colleague at Sustainn, and it's helping with managing the webinar, and Dorinde, this is the project coordinator that is going to give us an introduction about the project. We are recording the session because we will upload the session to the Innoaqua project YouTube channel, and Ayelen is gonna put some links in the chat. So there is a Q&A space at the end of the session, so we can discuss everything you need, every questions. And we will try to answer your questions and comments. Okay, so first of all, the agenda and the program for today is our project coordinator Dorinde. It's gonna give us an introduction to the project, and later we will go deeply into the sustainability and security assessment issues. So, Dorinde, please, floor is yours.
Super, thank you so much. Let me share my screen. Okay, if you can't see it well, then please let me know. But yeah, so today is about Innoaqua, and Innoaqua is very much about sustainable aquaculture practices for innovative seafood products. So our main aim is to look at the European land-based aquaculture industry and try to diversify its products and its processes and make it more sustainable. And especially the sustainable part Carlos will go into later. But the idea is to do that by integrating algae production in land-based IMTA systems, so integrated multi-trophic aquaculture, and using then the produced algae and also waste streams from the fish for the production of foods. So we're very much based around this technological backbone that starts with the cultivation. So here we have 2 demonstration sites, one on salmon and microalgae, and one on sole and seaweed. And so we have that a bit more here. So in Norway, we have, as mentioned, salmon production in RAS, so recirculating aquaculture systems, and we'll integrate the production of that. So using the water coming from the fish that's still rich in nutrients to grow microalgae, and also looking at can we valorize the sludge further. And then we do the same thing in Portugal, where we integrate the production of sole with the production of macroalgae or seaweeds. And we're not just looking at the integration part, but also how can we optimize it, and optimization, for example, by smart monitoring and digitalization of the process, etc. And then once we have produced all this biomass, the idea is to turn that into products and mainly food products. So we'll use this cascading biorefinery approach, extracting all the different fractions of the microalgae, of the macroalgae, but also of the fish processing waste. So the fish parts that currently don't have a use yet as foods. And to extract the oils, to extract the proteins, and all these different ingredients that we can get from these biomasses, and then turn them into ingredients that can be used in, for example, vegan meat analogues or vegan fish analogues, also other vegan products, but also hybrid products, so including the algae and the fish parts, for example, and all the aspects that we cannot use as ingredients in food, and that's going to be especially the carbohydrates. They will be turned into food packaging materials, so that also those will then hopefully be sustainable. So that's like our technological backbone, but to make sure that we develop products that are like interesting to our consumers and that our people are going to be interested to eat them, we have a large research aspect on also the social innovation. So that's understanding why people would or would not choose algae products, and also to use them to these consumers and to co-create products. So to understand what are they interested in, what would they be interested in. What would they be interested in? And for example, is it the taste more important, or is the fact that it's healthy more important, or sustainable? And to make sure that we design products and that make products that are going to be appealing then for consumers. Another very important aspect, of course, is what is today's theme. So that is the sustainability, safety, and regulations. Well, sustainability, Carlos will dive a lot more into. The other thing is, of course, that since we're using waste streams from aquaculture to produce these algae, we also need to make sure that we comply with safety and regulatory assessments. So we both try to understand what is, like in the technological backbone, what is the quality, for example, of all the products that we produce, and is it possible from a technological perspective to produce high quality feed ingredients, but also how do we align with current regulatory frameworks, and can we provide data to show that those frameworks maybe should be more feasible or more addressing what should be in a circular economy. Well, and then finally, last but not least, a big part is, of course, also our outreaching strategies, so to make sure that that everybody knows about the projects and all the results that we are creating. These are our partners. So we're a consortium of 17 partners from different countries. It's a combination of research institutes, of small and medium enterprises, and of different other organizations, for example, like the European Aquaculture Society. So as mentioned, we're spread from all over Europe. And we are a 4-year project. We're currently in month 19, so we're good on our way, and we'll be running until May 2027. As Carlos already mentioned as well, I'm the coordinator. So if you want to reach out to me, then this is my information. And if you would like to know more about the project, then I highly recommend you to either visit our website or follow us on our social media on LinkedIn and Twitter. And with that, I would like to give the word back to Carlos.
Thank you so much, Dorinda. Let's go deeply into the sustainability and circularity assessment. As I mentioned before, well, my name is Carlos Leon. I'm the Chief Innovation Officer of Sustainn. We are a circular economy and in sustainability consulting company based in Spain. And our purpose today is try to share with all of you with this our approach, because the project started in June 23 and it's going to be running until 27. So we are just starting to define the approach of the sustainability and circularity assessment. So we are leading the work package 5, as Dorina mentioned, related to sustainability, safety and regulation. And our goal in this work package is to evaluate the sustainability performance in the 3 dimensions: environmental, economic and social, circularity, and also to perform regulatory and safety assessment, but it is not the issue of today right now. So the work package is split in 4 tasks, as you can see, and the sustainability and circularity assessment is split in 2 main tasks in terms of, let's say, project organization, like this, the socioeconomic impact assessment and life cycle sustainability and circularity assessment. So regarding the social and economical impacts, the goal of this part is to assess the social and economical impact as a project from all the Innoaqua innovations, ingredients and technologies, ingredients and products to be developed within the project. And another level to analyze the social and economic impacts on ingredients and products level. So I will go deeply into that later, but the economical assessment will be developed following life cycle cost techniques, and the social impact assessment will be performed according to recognized references to analyze the social impact of the ingredients and products all along the life cycle of them. More or less the same approach in 2 different levels for life cycle sustainability and circularity assessment to analyze the sustainability and circularity impacts as a project. At the ingredients and products level, we will go deeply into analyze the environmental impacts following life cycle assessment techniques. And later we'll combine life cycle costing, social impact and life cycle assessment into sustainability assessment. And in parallel, we will run a circularity assessment of the ingredients and products all along the life cycle. So you can see here the approach of this part, the social and economical impact assessment. As I mentioned, we are we are going to do the assessment at 2 different levels, at the project level and ingredients and product levels. But the first thing it's important is to consider the needs and expectations from the stakeholders. Dorina was mentioning that there is a work package about the social innovations and the co-creation with the stakeholders about the ingredients and products. So in this case, it's so important to know which are the needs and expectations in terms of sustainability and circularity information, for example, that they need to know from the project. So we are working on that, and we will try to analyze which the specific information they need about social and economical impacts and sustainability and circularity assessment. Okay, so there is a project level approach and ingredients and products levels that we go deeply into that later. And the last part is to analyze how the project is aligned and contributed to the most relevant international policies related to sustainability and circularity, and we will try to analyze how the project is contributing to the specific targets of the Sustainable Development Goals, for example, to most relevant indicators in the European Green Deal and the Farm to Fork strategy, and finally to analyze how the project could contribute to some specific indicators defined by the Resilience Task Force from the European Union. Resilience Task Force from the European Commission is defining a set of indicators in order to see which are the capabilities and vulnerabilities of the different member states related to green transition, digital transition, and geopolitical transition as well. So we will go now a little bit more into details about the project level approach assessment. So here we are defining different impact categories in the economic dimension and in the social dimension as well. And regarding the economic impact or the economic dimensions, we will try to analyze how the project is contributing to reduce the waste, because there is a zero waste approach in the project, and try to measure which the waste generator, all the alternatives and activities to minimize that, and to try to recirculate the different waste, or to try to generate value from the use of waste and byproducts as well. And we will try to measure which is the, let's say, efficiency in the use and consumption of water as well. We will try to analyze how the project is to gain some market share and potential revenue from the ingredients and commercial products when eventually are going to be commercialized. And finally, try to analyze let's say the efficiency in manufacturing cost and the efficiency in the use of the different resources to produce proteins and functional ingredients, and finally products. And we will try to compare with the conventional alternatives that there are already in the market. Regarding the social dimensions, we will try to measure which are the jobs that the project could create all along the development of the projects, and also the potential jobs that could be generated because of the commercialization of ingredients and products and other key exploitable results. How the project is contributing to put on the market alternative proteins, because well, it's a need for the humankind, let's say, to generate food with the maximum efficiency of consumption of resources. And as Doreen was mentioned, there is a work package. There is a work package in the project trying to related to outreach. So we need to measure how the project is contributing for the development of skills related to algae-based products and ingredients development. And finally, we will work to try to measure which is the avoided societal cost derived from the potential commercialization of ingredients and products developed by the project in comparison with conventional alternative products. There are some studies now connecting the carbon footprint of a product, for example, to the societal cost. The societal cost is the cost that the current generations and the future generations have to invest or expend to, for example, for the health prevention, for mitigation of climate change, and other things. Regarding to life cycle sustainability and circularity assessment, the approach is the same. We will also try to measure sustainability and circularity at two levels, as the project level and ingredients and products levels, and the approach is more or less the same. We will go deeply later into the ingredients and products levels and to comment more about the life cycle assessment. But in the case of this part, as we are measuring in socio-economic impact assessment of the project, the social and economic dimensions, we will measure here the environmental impact and the circularity impact of the project. And finally, trying to analyze which is the alignment and contribution to international policies, but more focused on on the global sustainability and circularity as well. So okay, sorry, I think we have a problem with the Teams. No, Ayalen was not. Okay, we'll continue. Sorry, I think my colleague Ayala was out because of the problem of the Teams. Okay, I'm sorry. Well, we can continue. Okay, so going deeply into the environmental impact dimensions at the project level, we will try to measure related to carbon emissions or greenhouse gases emissions, which is the potential carbon footprint of ingredients and products when commercialized, and which could be the avoided emissions in comparison to conventional products already in the market. We will measure again as well the water footprint of these ingredients and products when commercialized, and which could be the avoided water footprint in comparison to conventional products, because we are trying to be so efficient in the use of water. And finally, to analyze which is the land use footprint, and to analyze which could be the potential land use footprint of ingredients and products when eventually are commercialized at the end, and to compare this the land use footprint in comparison to conventional products as well. And the other approach we will share with you, and we are working on, is that we are performing all these assessment, socioeconomic, environmental impacts, and circularity impacts from technology to market. So I think we have a problem with the microphones or something.
We can still hear you well. It just the sound changed a bit, but we hear you well.
Okay, thank you. Okay, so we are trying to perform these assessments from technology development at the lab scale up to the let's say the industrialization and serial production of ingredients and products as well. So we will try to start the assessments in this social, economic, environmental, and circularity from the lab scale and kitchen processes, and covering all the cultivation processes, the processing and extraction, and the cascade extraction processes into the up to the formulation of ingredients and products as well. We are using this approach because we think it is so important to identify the critical parameters at these scales, the lab scales and kitchen processes, in order to detect which could be the most important things in terms of sustainability and circularity to consider in the scale up in the industrialization and serial production of the project. And we are, let's say, expanding this assessment for the 10 ingredients and 14 products that are going to be prototyped within the project. So this is the approach. It has no sense to analyze a lab scale process, but the thing here is that we need to, let's say, what is important in a lab scale is, of course, to demonstrate that the process is feasible and the product is going to be feasible at the end. But in terms of sustainability and circularity, when we are developing technologies, we have to ensure that these technologies are to be sustainable, or at least the ingredients and products resulting from these technology development processes are the most optimum solutions in terms of sustainability and circularity as well. So going deeply into the ingredients and products level, as I mentioned more or less before, within the social and economical impact assessment, we are going to perform different life cycle assessments. So life cycle assessment in order to know the social or to estimate the social impact of ingredients and products in different stakeholders. And of course, we have to analyze the economic impact of ingredients and products, and to analyze the cost all along the life cycle of these ingredients and products. For doing this, it's very important and needed, of course, the mapping of all Innoaqua processes, and I will go deeply into that in the next slides. And with this social life cycle and life cycle costing assessments, and combining with the environmental impact assessment of the life cycle assessment, we will try to perform a life cycle sustainability assessment, combining the social, economic, and environmental impact assessment in the 3 dimensions. And in parallel, we will perform a circularity assessment of the life cycle of the different products. So for doing that, we have defined a methodology for the sustainability and circularity assessment of ingredients and products, and with these 4 steps. And the first one is the value stream mapping, and it's so important going to the details into the different operations and different raw materials, substances, resources that we are consuming, and the waste that is going to be generated in every operation. Later, that with this value stream mapping, we can perform the next circularity and sustainability assessment, and in the specific dimensions, environmental, costs, and social. And finally, with all of these assessments, we can work on in the identification of critical parameters from the lab scale and kitchen processes in order to detect, let's say, potential hurdles or potential things to work on in order to get, as I mentioned before, the optimum solutions and ingredients and products in terms of sustainability and circularity. So going more into details about this. So the first step, the value stream mapping, it's in the ingredients and products levels. We need to go at the deeply into every operation in order to detect which of these arrows are the critical parameters in terms of environmental impacts or in terms of costs. So we need to map all the operations in these different phases Donnie was mentioning, as cultivation, extraction and processing, and formulation of ingredients and products. So we are working on this with different partners, leading the other work packages to build the maps of all the project operations in order to have the, let's say, the whole perspective from lab scale up, industrialization, and finally formulation of ingredients and products. So we will have these maps for every of these ingredients and products I mentioned before, that the product is going to prototype. So maybe the map for ingredients and products could be a little bit different, sorry, but anyway, the approach is that we have to go into every operation, every arrow that for example, resources and substances and materials we are consuming, and the different kind of waste that we are generating in every operation. Okay, one important thing to consider here in order to perform some sensitivity analysis at the end is to consider the different potential scenarios that we can have. Well, this is another example of packaging, but imagine that when we are manufacturing something, we can have different kind of different suppliers for same materials. So we could have different scenarios in order to identify different costs and different environmental impacts. And we think that distribution and commercialization path, it's different if we are, for example, distributing one specific product for a logistic platform or for a processing company or aquaculture company or whatever. So the path that is being built, let's say, it's different. So every scenario could have different impacts in general in the 3 dimensions. But this thing is just to detect which could be the critical parameters and the variability of these critical parameters depending on different scenarios. Because, for example, if we are cultivating microalgae or macroalgae, for example, in Norway or in Portugal or in another country, of course, there are different scenarios to for the final ingredients and products, considering different costs in different countries, consider different transportation operations and all these things. So this could be important, and we will try to analyze at least the most relevant scenarios that could happen in the different ingredients and products as well. So Well, this is just an example of one of the maps that we are defining. In this case, this is for a specific task about the extractions from microalgae in order to obtain different kind of ingredients that are to be prototype and to be used in the different products at the end in the work package 4. So, and we are trying to identify right now, as the project is running, we have the process more or less clear at the lab scale, and we are working in the project in the next steps, like the pre-ingredients scale, industrial scales, and finally the commercial scales that it could be developed outside the project, after the project. So we will try to see here if the process is changing in the different next steps and how they are changing as well. So this is the thing that we are trying to cover from technology development processes to the scale up and industrialization in order to know which could be the changes. For example, imagine that we are detecting in these operations that the energy consumption is so huge, and this is one critical parameter at the lab scale. So when we are changing the processes in order to get, say, volume of these ingredients and finally products, this consumption could be the same because we are going to use different equipments and machinery in the process. And if this is different, how is different? And if this critical parameter could be the same, or we have to consider something in order to optimize the consumption of energy in the different next steps. So this is the thing about considering from technology into the, let's say, serial production. And once we have all these maps, imagine that we have 10 ingredients and 14 products, and imagine that we could have different scenarios for every ingredients and products. So we could have a lot of different maps, and imagine that we are mapping lab scale, scale up and industrialization. We could have, let's say, a huge combination of maps. We will try to analyze the circularity and sustainability. So regarding circularity assessment, we will work on identifying the different circularity categories, circularity indicators categories, and try to identify and measure the most relevant circularity indicators in order to be aligned to the circular economy principles like this, regenerate nature, circulate products and materials, and eliminate waste and pollution. So for doing this, we will follow the recent published circular economy ISO standards, the ISO 59000 series, and specifically 59020, that it's defining principles and guidance for measurement and evaluation of circularity. So most relevant indicators are related to these categories, so resource inflows, resource outflows, energy and water consumption. So we will try to define and to measure indicators for all, for the different ingredients and products, and with all the information we have from the value stream mapping. Regarding sustainability, at this step, it's clear that we have to, at least we need to try to assess the 3 dimensions: social, economic, and environmental. So we are, based on a life cycle sustainability assessment approach, we have to combine the 3 dimensions. And we are using life cycle assessment techniques in order to identify the environmental aspect and impact, life cycle costing techniques in order to calculate and evaluate the cumulative cost of a product in its life cycle, and finally the social impact of the life cycle of the different ingredients and products. Regarding environmental impact assessment, I'm not going to go into details about this because this is not the issue of the session, but it's so important to define here which is the system boundaries. So when are we starting to measure and when we are, let's say, finishing the measurement, And of course, to define a functional unit to measure on the impacts, for example. And in this case of food products, the functional unit to measure all the impact is normally 1 kilo of ingredient or products. And it's so important to follow the product category rules. Product category rules are documents defining how to perform a life cycle assessment for a specific product category. And in this case, we will follow the food and beverages available product category rules. So at the end, we will have a set of environmental impact categories and indicators, and we will measure these kind of, and we will have values for different ingredients and products all along the life cycle in these environmental impact categories. And for example, the most relevant thing we are working on is to calculate the product or ingredient carbon footprint in order to know which are the greenhouse gases emitted during the entire life cycle of a product. Regarding the cost assessment, life cycle costing technique is a well-known technique in order to analyze the cost impacts and to calculate the different unitary costs all along the life cycle product. So we have to consider all the different phases all along the life cycle, like the concept design and development, in this case, the technology development phase, the part of manufacturing cost, including the bill of materials, the cost of the different substances, materials that we are using in all these maps and operations, manufacturing costs, we will try to analyze and measure and calculate the labor cost, for example, that it's going to be different in different countries. So this could be an important thing to pay attention. Well, this is just, we don't have installation here, but we will have in transportation of distribution of products, and there is no operation or maintenance in this kind of food products, but we have to take care about disposal thing in terms of mainly the packaging of these ingredients and products as well. So with this cost assessment, we will have the distribution of cost of every ingredient and product all on the different life cycles, and we will have information and we have a perspective about which is the phase of with the greatest impact in cost, and which we could work as well in the variability of cost in the different phases in order to identify, okay, which could be the critical parameters and which could be the variability of these critical parameters. For example, if we are thinking about manufacturing or development of ingredient and product, we could think about the labor cost, that it's going to be different in different countries. So we will see which is the impact in the whole life cycle cost. Regarding the social impact of the life cycle assessment, it's not so common to do this assessment right now in, let's say, in cereal production or in a product in the market. But there are some studies and references, for example, for the environmental program of the United Nations in order to calculate which is the social impact of the life cycle of a product in the different stakeholders. So it's working more or less the same way that in the environmental and cost dimensions, because there are some impact categories defined. So for every of these impact categories, we can define a specific indicator. So we will try to measure which is the specific impact in different impact categories on different stakeholder categories. So like workers, local community, society, like for example, future generations, like consumers that we are going to work in the Work Package 1 with the co-creation with a co-creation process with them, and to analyze which could be another, let's say, social and economical repercussions for other value chain actors. And with all of this, we will have some, this is just an example, we will have values for this environmental impacts and life cycle cost, and even for the social life cycle in the different category inputs and indicators. And with these, okay, we will have a lot of different numbers and different magnitudes. So we need to work on trying to combine all of them, combine different dimensions, like for example, CO2 kilograms of the carbon footprint of a specific product with euros of bill of materials, for example. So next step is trying to compare different products. Imagine that we have to compare all the ingredients and products we are developing with a conventional product already in the market. So we need to try to normalize specific indicators in order to compare to maximum or minimum values, and then it will be useful for comparing environmental dimensions with the cost dimensions as well. So we are investigating right now about which could be the best techniques in order to normalize and try to combine different magnitudes from the different dimensions. But one would be the a simple normalization procedure in order to compare the different alternatives. In this case, in the environmental dimension, but we could use the same thing to for the life cycle cost, for the cost dimension, and even for the social impact dimensions with different impacts. And we could weigh let's say we can in order to see which could be the most important things, for example, within the environmental dimension or within the costing dimension. And with these, and trying to weigh these three dimensions with a simple way of let's say defining let's say percentage of importance, so to say, we could work a sustainability overall score at the end. So there are some recent studies about this with different techniques with where when you are combining different magnitudes and units of different indicators, how to combine all of them. So we will try to get the sustainability overall score of specific ingredient or specific products in order to compare them within them and with other conventional products already in the market. And finally, the last step is sustainability security assessment. We call it this way. We will work here in trying to identify which are the critical parameters in related to environmental dimension, cost dimension, social dimension, and in parallel circularity. So we need to identify which is the phase of the life cycle with the greatest impact on a specific indicator. For example, which is the phase of the life cycle of a particular ingredient related to the carbon footprint. So we need to identify, okay, this is the manufacturing phase. And after that, within the manufacturing phase, which is the specific operation that we saw in these maps, which is, let's say, contributing with the greatest impact in carbon footprint. And after that, we will go deeply into, okay, in this operation, the specific parameter that is contributing to the carbon footprint in a greatest way is, for example, the energy consumption, depending on the kind of, let's say, of fuel you are using, for example. And with this, we can work about sensitivity analysis against these critical parameters related to the specific dimensions or related to the overall sustainability assessment. And with all of this, we can work about the identification of risks and opportunities, for example, related to volatility of cost of raw materials, or legislation trends, or customer trends, or wherever we have to identify in order to know more about the risks and opportunities we can have right now that we are developing the technologies, and maybe we are in time to do something in the scale up or industrialization, or at the end to prepare for the developers of ingredients and products to get to attain the optimal solution of ingredients and products in terms of sustainability and circularity. So finishing, it was quick, but we wanted to share with all of you which is going to be the approach of performing assessment in sustainability and circularity within the Innoaqua project. trying to cover these two approaches as a project level, which could be the impact of the project in the different in these three dimensions and circularity as well, and going into the ingredients and products level, which is going to be the approach to combine all the assessments in the different dimensions in order to get a sustainability overall score and circularity measurement as well. And the other important part is the approach from technology to market, because we think that it's very important to identify which are the critical parameters in terms of sustainability and circularity from the lab scale and the kitchen processes and the technology development processes in order to prepare the scale-up, industrialization, and final and eventual commercialization of ingredients and products. So, well, it was the material we have prepared for today, and we are open for your questions and doubts and comments. Thank you very much for being so patient and paying attention to this. Hi, Cornelia.
Hi, Dorinde. Very nice to join this webinar and learn about the project. Really impressive. I don't know if this question is to Dorinde or to you as well, Leon. So you have used 3 algae species, and I'm curious, so far, do you see any differences in terms of sustainability, circularity? Can you say anything? Which one would be better than the other one?
Yeah, so we have 3 microalgal species and then at least 2 macro. For the microalgae, so I don't think Carlos has not done all the calculations, but so the thing is that salmon is grows in fresh water in the beginning of its life stage, and then has a shorter or longer brackish water stage, and then goes to salt water. And we do see, so that's why we have the 3 different algae, to make sure that we always have the right algae for the right water quality, so to say. But with having the fish size also changes, and the amount of nutrients that are in the water. So it's not necessarily algae-based in a way, the sustainability, but also like the uptake efficiencies and how much biomass, microalgal biomass, you can produce on how much nutrients. It's a little bit of a difference between species, but it's also on how much water you need to provide enough nutrients to produce a kilogram of water is going to be different because of the different concentrations of nutrients that we see. So that is going to be different. But the thing is, and that's also, so now we're doing these experiments with Marine Almond Ras Lab, which is a research facility. So there we really have 1 reactor of algae connected to 1 tank of fish. But the thing that we're also now going to have a discussion on with Innoaqua, which is the other partner, is that, so Innoaqua, they are planning to really produce salmon from like tiny fish to the 5 kilogram fish that are ready for consumption. And normally the current facilities, so to say, of salmon, they mainly go to this like post-smolt phase where the fish are still relatively small, and then they go to sea. So I guess sustainability in that sense is going to be anyways a question of what facility of fish do you connect with what facility of microalgae. But the other thing is that probably So I'm not 100% sure yet how Viking Aqua is collecting all their water. If they combine all the water from all the tanks, and if that does, it's going to mean that you end up with a mixed water that is relatively salt water, because bigger fish need bigger tanks, more water, and thus that's going to be the main component of the effluent water. Or if they are really just the water goes out per tank. Also, this is now we've done the research mainly on the effluent water of the fish tanks. So that's the bleed rate, so to say, with which they refresh the water in those fish tanks. But you also have water coming from the dewatering of the sludge, which is more nutrient rich. So how that is all going to be looking at the real large-scale facility and how it makes most sense to design then the algae facility in combination with the fish facility, that's not 100% clear yet. And that's where we now are having discussions with the fish producers. And I could imagine that it's also then going to be different per location, so that the answer might actually differ per location. So I cannot say that one algae is the more sustainable one. That's a very short answer to the long answer.
On the fish.
Yeah.
Okay, very nice. Thank you.
From my perspective, I think on Friday we were discussing about this. Is that if you are scaling up the process, is which part is going to be optimized? I mean, in terms of efficiency of the final ingredients and products you are obtaining, and with these approaches from technology to marketing in terms of sustainability and circularity, we need to see this. I mean, which could be the best combination of our algae installations, equipments, connection with fish equipment, tanks, different countries, in order to get the optimum solution in terms of sustainability and circularity. Of course, the technology is being developed for getting a product. And this is the main thing is to ensure feasibility of a product in terms of safety, of market acceptance, and all these things. So we're introducing the sustainability, let's say, perspective into this in order to get the optimum product should be optimum in cost and impacts in, let's say, environmental impacts. And there are a lot of different parameters and aspects, like Doreen is saying, that could affect, but we don't know yet how. So we need to start having try to obtain numbers, and this is to go into the operations and different combination of operations with maps and scenarios and all these things. This is the important thing of this, in order to try to answer your question.
Yeah. And actually, I have a question because a couple of slides ago, you in the overall calculation, so to say, you said that now I don't know the exact word, but like you gave a factor to the environmental impact, the costs, and the social impacts. And oh yeah, here. No, one slide back, I guess. Yeah, here, the company strategy. So how much of this company strategy is like, how do you say that? Like is aligned over the whole of Europe, for example, because that's the way you can then compare, or how much is truly a company strategy?
Yeah. Well, this is extracted from another studies, and this is just an example. And where, for example, imagine that the product developer, it should have, let's say, a very defined strategy in order to, okay, I have to be competitive in cost, in quality, or in sustainability. You know, so this is a very simplified, let's say, process in order to get some numbers into, okay, we are more concerned about the cost and later social and environmental, right? So yeah, we will have to work on this because of course it could depend on the company's strategy, or it could depend on, okay, this is the, let's say, the principles of the project or the European project, maybe, right? It's okay, we are trying to get some products and innovations to the market, so we need to look at this, but we need to look at this as well. So which is the ponderation or the weight of all of them? So we need to work on this. Yes. Okay. Any other comments, doubts, questions?
Maybe, Cornelia, I can add a link in the chat of one of the papers that just came out of Innoaqua, and where we used only the effluent water to grow freshwater, brackish water, and seawater strains. And there we looked both at the performance in terms of nutrient uptake, but also the sustainability and that's environmental and economic of different technologies. So that's maybe already a little bit of an answer on your question.
Yeah, interesting. But of course, if you also compare macro and the microalgae, which one are more efficient to take up the nutrients? Is it micro? Can you say?
No,
Or
I
these are
don't think so.
different
And
sites.
and so first of all, it's different sites. It's Portugal versus Norway, so that's going to be a difference. And the other thing is that, and so that you will see in the paper. But the nice thing with macroalgae is you can keep them easier in the reactor, so you can flow. So if you have like a lot of water but relatively low in nutrients, it's very easy to treat a lot of the water because the algae are staying in the reactor much more easy when it's a seaweed than it's when it's a microalgae. So in the paper that I just added in the chat, there we actually either added nutrients to come to the normal concentrations we would normally use at large-scale industrial microalgae production, or we had a system by filtrating the algae and putting them back in the reactor to be able to treat more water, and so have the same amount of nutrients, so to say, but just by producing or by having 4 times more water go through the reactor. But that has a cost in filtration and in energy and in systems, and like a literal economic cost and an environmental cost. So and that's going to be different than the macroalgae part. So we did not do the calculations yet for the comparison microalgae, macroalgae. It's probably also going to be quite difficult in the sense that also the fish are different, and the amount of nutrients that are in the water will be dependent on the fish, the fish species, but also the production location and how they operate their systems and everything. So yeah, I'm not sure if how much of a comparison in the end we can do, but at least we can say if the hotspots, for example, in the process are the same, whether you have macroalgae or microalgae, or if also that changes, for example, in terms of what causes the most economic or environmental or social impacts. So that I hope that with Innoaqua can say, but it's going to be difficult to say macroalgae or microalgae are better. Yeah, that's.
You need to have the whole process from the cultivation to the product. That one has to be compared, maybe.
Yeah.
Then,
and then the other
the
thing
same
is,
steps.
Yeah, and the other thing is also the nutrient composition of these algae is different. So how are you then going to compare? Because then the product might also be different. So one has more lipids, the other one has maybe more carbohydrates or proteins. So are you then going to go for nutritional value or per kilogram of just algae? Or so there's so many variables and so many questions, and yeah, it's going to be a very much if then answer, so to say. Yeah.
I was also curious, the carbohydrates from macroalgae, are they also for packaging, or what would you be using
that would be
them
the
for?
idea. Yeah, that would be the idea that they all go, but that's a test. So that's very much a hypothesis until now. Yeah, so I think it's Innoaqua that does the packaging, and they have a lot of experience with the carbohydrates from seaweeds for packaging. So I think there we're quite sure that that's going to work. But the microalgae fraction, we're not. That's still a hypothesis, so that we'll test. Yeah, and that might depend also on the extraction technologies used before. Whether you end up with a fraction that is usable or not, depending on whether that's like mechanical extraction or a solvent extraction or those kind of things.
Among the species that you are using, both micro and macro, are they novel foods? Because you want to use them for different food products. How are you going to deal with, and the issue of waste?
Yeah, true. So that's the reason also why we chose these species. So we have Chlorella soroconiana that is allowed. And then we have Phaeodactylum tricornutum that there's some applications ongoing. One of them has been declined, but the other one I think is still ongoing in the novel food list. And Nanochloropsis oculata is allowed in the United States at least already. And there is companies looking into novel food application. So we have a feeling, and they have already good results. So there's the gossip, so to say, that they expect to be able to get through novel food applications. So that's why we chose these species, to be like on the not so novel to novel side, but hopefully close to potential commercialization. But then you have the whole regulations aspect, which is still, so the way the value chain is decided now, that's not allowed either, to use aquaculture water for microalgae to then use food. So that's another challenge. Yeah,
but it's possible to get funding for this so far.
Yes, and we have good
the
hopes
macroalgae,
that we can.
The macroalgae species, they are
I
allowed?
think all three are allowed now, because there's this I think earlier this year, there has been a lot of effort in showing that there is more macroalgal species that were already consumed before 1997. So the list has been expanded quite a bit, and there were mainly macroalgae that are now also on the list of not even novel food, but like food consumed before 1997. So approved as food.
Okay, thank you very much. Good luck. Yeah. I will be following the project. Already I do that. Thank you.
Perfect. Thanks.
Wonderful to join this webinar.
Good to have you.
Thank you. Yeah.
So, well, it's we are on the limit of time. Any other questions, comments, doubts?
See one more hand of Resti.
Yes.
Hey,
Resti.
Hello, I'm from Indonesia. Hi. Thank you for giving us this webinar. It is very inspiring. I have a question that right now we are currently developing the spirulina microalgae. I think it is a widely known one. And we have several ponds here, and it is interesting since we haven't tried to have some approach like what you are going to do in the future with this project. So I would like to know, is it applicable for us also to also use your approach to get the social or maybe the energy, the emission, and etc. So we can also try to estimate and to calculate whether our project, our current project, is sustainable or not. And then my second question is, we are also trying to develop the RIS system here, but with the shrimp pond. So we tried to develop the Thalassiosera, it's the diatom one, and also the Cetoceras calcitrans. We try to cultivate it in the wastewater coming from the shrimp farming effluent ponds, and we try to give it back to the larvae. But apparently it's still difficult for us to get a better result compared to use the pure one. Maybe you have any in innovation or maybe sources or technology that already well applied while we are using the RIS system. Thank you.
Well, I think I can go for the first one. Well, all these things that we are sharing with you are gonna be public in a deliverable, in 2 deliverables. In fact, I guess in 2 or 3 months will be available from our website. So yeah, it's free to use. Everything we can put in those deliverables. So, and anyway, any things that you would like to know apart from this, you can contact us freely. So this is from the first one. From the second one, I'm afraid I'm not an expert. So maybe Dorinda can add something. I don't know.
So I'm not a fish or a shrimp expert. I do know that there is more people using RAS for shrimp, so I would assume it's possible. But no, I don't dare to give you any details on that. Yeah, and how do you say it? Like from the integration perspective, I would guess it's relatively similar. in the sense that there's a lot of dissolved nutrients that you could use for your microalgae, so that should all be possible. Some of the things that we're now also looking into is so the main what we started with was like the main nutrients, like nitrogen and phosphorus, and see if they were available for the algae, and that they are. And now we're diving into the details. Like I know that in salmon feed, for example, there's quite a lot of copper and zinc. Where are they? Are they in the sludge or are they in the water? And even if it's in low quantities of water, will the algae accumulate them, and how will that influence the effect on the quality of the biomass? So I could imagine that, for example, with shrimp, you will have potentially other elements or aspects that might influence the integration with the algae that you would need to be aware of or look into. But I think the general idea of using the water from shrimp for algae should very much be possible. I guess most shrimp also grow at higher temperatures, so choice of algae there might be maybe something to look into. Salmon likes it cold. At the same time, we heat up the water relatively fast with the fact that we use quite a bit of illumination. So yeah, that would be the things that I can predict.
Okay, so you mentioned that as long as we can manage the nitrogen and phosphor for the microalgae, it would be okay for the culture. So how do you usually manage to get the constant nitrogen or phosphor coming from the effluent in the project that you currently doing right now?
Yeah, so that's a challenge, and at the moment we see a bit of fluctuations, and also how do you say that in general, but also affected by the operation of so whether they clean, for example, the RAS or not. But the one aspect that I haven't shown yet, because it's still like ongoing research without results, but one partner in Innoaqua, they're developing sensors specifically for the nutrients. So the idea would be that you then can and this whole like artificial intelligence backbone of how do you say it, like process control. So the idea would be that you can actually steer the inflow of your water based on the amount of nutrients that you have, or based on the amount of nutrients that are leaving your algae reactor, for example. But that you can have these feedback loops by smart sensors and smart control technology, so that you can really fluctuate the inflows or the outflows, and thus have a very constant production process for your algae, so to say. But the sensors are currently in development, so we haven't tested them in application with microalgae. So I hope months is too early, but in a year from now, for example, there will be information on how this works in real time, I hope. Yeah, but that I think is a way to go. So either you will have to deal with the fact that the quality of your outgoing water might not be constant, or which is also a possibility, I guess, or indeed it's like the smart control technology that I think is going to be very promising.
Yeah, thank you. I think that's the only answer that we have right now for managing the nutrient and the phosphor by using the effluent. Thank you very much. Thank you, Carlos.
Thank you. Okay, so I think it's the 9:11 here. So, well, we will upload the video to the YouTube channel, and we will send you an email informing you. So thank you very much. Thank you, Dorinda. Thank you, Ellen, for helping me. And yeah, I recommend you to follow Innoaqua in our social media and the website. And yeah, see you soon. Thank you.
Thank you very much, Carlos and Ellen. Thanks all.
Thank you.
Thank you.
Bye-bye.
Bye-bye.